Hello Bobcats. Today in this video we're going to discuss quantum numbers and do some practice on quantum number sets. So just a reminder, our quantum numbers, we have the principal quantum number N, which is our energy levels 1 through 7. Then we have the angular momentum principal quantum number L, which represents the sublevels. 0 would be the number for S, 1 for P, 2 for D, and 3 for F. Then we have our magnetic quantum numbers, M sub L, which represent the orbitals, and I'll go through more of those numbers as I do the video. And then we have our spin quantum number, which indicates a plus 1/2 spin would be the clockwise, which I'm indicating with an up arrow. A negative 1/2 spin would be counterclockwise, which is what I'm representing with a down arrow on my orbital diagrams. So what quantum numbers do are, it's kind of like an address for the electron, and it could be for any electron in the atom, but today I'm actually going to be looking at the last, we're going to be doing the quantum sets for the last electron that's placed in the orbital diagrams. So when we talk about a set, when I say a set of quantum numbers, that is a set where you have N, L, M sub L, and then M sub S. Okay, so we have our 4 quantum numbers. It's kind of like an address for the electron. So let's look at the first element we're going to look at is nitrogen. And so to do quantum numbers, the easiest way that I've found to do it is to actually do the orbital diagram first. So for N, I'm going to write the symbol for the element, and then we have 1s12, then 2s12, and then 3p123. So I'm going to have the 1s, the 2s, and then the 2p. So 1s, 2s, 2p. And nitrogen, remember, has a total of 7 electrons. So I'm going to put those in. I've got 1, 2, 3, 4, 5, 6, 7. Now again, I want to look at this. We're going to do the quantum number set for this last electron. It could be for any of them, but I'm choosing to do it for the last electron today. And if I go through that, my quantum set would be, I have to look at the energy level N, which would be energy level 2. Then the quantum number L represents this sublevel, and my sublevel is P. And so you can see here that P is represented with the number 1 quantum number. And then our orbitals. So remember, on the orbitals, the numbers went -1, 0, +1. And so that electron is in the +1 orbital. And so I'm going to put a 1 there, and that is also an up arrow, so I'm going to represent that with a +1/2. So it's a +1/2. So this is the quantum set for that electron in that element. Let's take a look at a different element. So let's look at iron in this case. Now iron is right here, located right here. Okay, and iron has 26 electrons. So I'm going to start out with my orbital diagram to be able to do the quantum number Fe. Now in this case, I'm going to choose to do the noble gas notation. So I go up and over, and the first 18 electrons, or 3 energy levels that are full, can be represented with that noble gas, which happens to be argon. So there's 18 electrons accounted for. And then we're going to have the s orbital and then the 3 d orbitals. I'm not going to worry about the p because I don't get there. So I have the 4s, and then a 1, 2, 3, 4, 5, 3 d orbitals. Now I need to put in 26 electrons. I've got 18, 19, 20, 21, 22, 23, 24, 25, 26. So now I have my orbital diagram. I'm going to put the numbers down below for the orbitals. So that's going to be a -2, -1, 0, 1, 2. Now to do my quantum number, I'm going to look at the last electron here placed in this set. So for our quantum set, we're going to have, this is energy level 3, that's the N quantum number. The L quantum number is for the sublevel, it's D, and D is represented with number 2. And then our orbital that it lands in is the -2 orbital of the d orbitals, so it's a -2, and then it's a down arrow, so I'm going to use a -1/2. And that is my quantum set for that electron in this element. We're going to do one more, and then that'll be it for today. Let's look at bromine. Now we have bromine is sitting over here, and bromine has 35 electrons, and I can start out again with argon to represent the first 18. So we have bromine, and we're going to have argon, and when I start I have 4s, 3d, and then 4p. So I've got a 4s, the 3d, which has got 5 orbitals, and then the 3p, 1, 2, 3. I mean 4p. So that's 4s, 3d, 4p. And I've got to put in, again, 26 electrons for iron. So that's 18, 19, 20, 21, 22, 23, 24, 25, 27, 28, 29, 30. I'm sorry, and this is actually 35 for bromine. I said iron a minute ago, but it's 35 electrons for bromine. I'm at 30, 31, 32, 33, 34, 35. So there we have bromine's orbital diagram. I'm going to just write the quantum number set for this last electron. Remember, it could be any of them, but I'm choosing to do the last electron. So N, which is the energy level, is 4. L, which is the sublevel, we're in P, so that'd be 1. Then the orbital itself that it is in the, well, let me write those out again so we don't forget. -1, 0, 1. So it's in the 0 orbital. And it is a downspin, so I'm going to put a -1/2. And that's my quantum set for that electron. And that is another discussion and practice on quantum numbers. Have a good day.